All right, 1.3 models and applications. And appreciate that. If I ever get off track, I got like 5,000 classes. So if I ever get off track, feel free to, question or ask. I'm human. It's all good. So this first 1.3 is models and applications. And so the strategy, and let's say this, another word for applications are word problems. So strategy here, we have a 5-step strategy. We want to first, of course, read the problem. Make sure you understand the problem. Make sure you understand what's going on in the problem. Remember, no one knows how many times it took for you to read it. So take your time and read the problem. Make sure you understand what's going on. Steps 2 and 3, I put an asterisk beside them because most of the time that's where the challenge will come. It says, if necessary, write each unknown in terms of one variable. So if you have multiple unknowns, what you don't want to do is write X, Y, Z. Let's say you have 3 unknowns. You don't want to introduce multiple variables. All you want to do for these is to write one variable and then write the other one in terms of that variable. So you see what I mean in a second. The reason why you don't want multiple variables is because the more variables you introduce, the more equations you will need. Then we would need a system of equations, which would make things more complex, than necessary for these type of problems. Then we'll write an equation for the type of problem according to the words that are given to us in the problems, solve, and then check. And number 5 is important because we could actually do everything right and still not necessarily answer the problem, if we don't check and see what they actually asked for. So that's going to be our strategy. Let's see what's this. Oh yeah, don't worry about that in red. Erase that. All right, so let's go down to the first problem. Once again, I can't see everyone, so if I erase something, or if I'm not erase something, if I move too quick, and always make sure you say something so I can scroll back down. So it said the average yearly salary of a man with a bachelor's degree exceeds that of a man with an associate's degree by $25,000. The average yearly salary of a man with a master's degree exceeds that of a man with an associate's degree by $45,000. Combined, they earn $214,000. Find the yearly salary of each. I'll give you a chance to write. All right, so let's look at the problem. So we have a couple of unknowns here. We have, it says the average yearly salary of a man with a bachelor's degree exceeds that of a man with an associate's degree. So we have a man with a bachelor's, man with an associate's. And then we have the average yearly salary of a man with a master's exceeds that of a man with associates by 45,000. So I'm going to erase these just so we can walk through it. So we have these 3 unknowns. We have the associates, the bachelors, and the masters. And what I mentioned before is that we don't want to have, or we don't want to call this X, this Y, and this one Z. We want to call one of them X and write the other ones in terms of that X. So we notice that each of our sentences, they take one and describes it in terms of the associates. They got the bachelor and says that his exceeds that of a man with an associates by 25. Then we have the master's and his exceeds that of a man with an associates by 45. So what we can do is let the associates be X and then go back to our bachelors and say our bachelors would be X plus 25 because he exceeds that of a man with an associates by 25. And then the other one, the master's, would be X plus 45 because he exceeds that of a man with an associate's by 45. All right. So for number 2, that's step 2. You establish your unknowns and then write an algebraic representation for each unknown. Questions about that? X plus 25, X plus 45. All right. So then step 3 is to write an equation. Now there will be a key word or key phrase that will let us know how to set up our equation. And the key word here is combined. It says combined, they earned $214,000. So combined mathematically means when you add them together, they will equal to a certain amount, or in other words, in this case, 214. And so that's what I did right here. And those parentheses are just there just to signify, what was added together. We won't hold them there, but we're adding x plus 25, and x plus 45. When we add them together, it should equal to 214. All right. Questions on that? So now step 4, we go ahead and solve and walk through that. Like I said, those parentheses weren't needed, so we're going to add x, and x, add 25 and 45. So that'll give us 3x plus 70 equal to 214. Then subtract 70. So that'll be 3x. All right, so I had a question. Does it matter for the placement when creating the equation? When you say does it matter for the placement, what do you mean by that? It does in certain cases. It depends on what you're talking about, though. All right. Number order. So let me ask you this. When you say placement, are you talking about the placement? Oh, no, didn't mean to do that. Still was on erase. There we go. Are you talking about the placement of these? Placement of 3x. Let's see what we got going on here. Yes. No, it doesn't matter. Because addition is commutative. So 5 plus 2 and 2 plus 5 will still give you 7. So if you're talking about when it comes to adding, no, that doesn't matter. All right, cool. All right. So finish off the problem. You divide both sides by 3, and x is equal to 48. So before we make sure, step 5 is to check to make sure you actually answer the question. Any problems with getting to x equal to 48? All right. So now it says find the yearly salary of each. So if you plug in 48 for your answer, then you will get it probably incorrect. I think my math lab will give you a box for each one. So you probably know something else is needed. But let's say if it was a written test, and you just wrote 48, then the teacher was reserved the right to get, mark it wrong or just give you partial, because x equal to 48 only lets you know about what the associates earn. But then you have to plug in 48 right here. 48 plus that's 75 will be 73. And then 48 plus 45 will give you 92. And so those will be your three earnings, 3 salaries. All right. And all 3 of those should add up to give you 214. So don't forget that element of it as well. Just wait and check to make sure you have the correct values. All right. Questions before we go to the next one? All right, can I scroll up? Very good, good. Let me know. All right. So next one, your local computer store is having a sale on cameras. After a 40% price reduction, you purchase a camera for $276. What was the camera's price before the price reduction? All right. So I'll give you a chance to write that down for those who are doing so. All right. So when you look at just dealing with the relationship of having a sale, whether you've done retail or not, you know what has to occur is that there has to be an original price. Then you're gonna do your price reduction, so you're gonna subtract from the original price, and that will give you the sale price. So those are the three pieces that we would need for any sale that's going on in the store. You have an original price minus the price reduction, then that's the sale price that you're going to deal with on that day. So the first one, what we're trying to find out is the original price. So that's what we're going to call X. If I can erase. So we're going to call that X. The sale price they gave us, which is 276. So we already know two pieces of the equation. Now this third piece, well, it's the second piece of the equation, but it's the third piece that we need to figure out. A lot of people make a mistake here. They either will take 40%, they either will put 0.4 right here. But we have to first recognize that 40% you convert it to a decimal, you do your calculation, but it does not stand alone. You're doing 40% of something, and of mathematically means multiplication. But what you don't want to do is take 40% of 276. So a lot of times people make that mistake, wherein 276 did not exist until the price reduction occurred. So what you're going to do is that you will be taking 40% of the original price, and the original price is X. All right, so that's how you would set up this type of problem. You have your original price, which is what you would call X. Price reduction is the percentage converted to a decimal times X, and then that's going to be equal to your sales price. So, okay, got a question in the chat. We are trying to find how much money is we, no, we're trying to find, it says, what was the camera's price before the reduction? So we're looking for the original price.
How did 4.4 become 0.6? Maybe
Well, we're gonna get there. Yeah, we haven't gotten there yet.
Oh, okay.
Yeah, I
Sorry.
just want to make sure we're good with getting here and giving people a chance to write and everything. All right. So then we got another question. Oh, it said we are trying to find. Yeah. We got it. All right. So now, great question. How do we get to the next step? And this is another place where a lot of people make a mistake. So now, when we see our X terms, we know the next move is to combine our like terms. What we don't want to forget is that, yes, we have 0.4 right here, but there's a 1 that is sitting in front of X. So when you do your subtraction, that's going to be 1.0 minus 0.4, which is how we get that 0.6. All right. Make sure we are okay.
Where do you get the 1.0 from?
Right here, whenever you have just a variable, is assume there's a 1 sitting in front.
Okay.
And so when you go to do your subtraction, because you have the 0.4, then you add the 0.0 behind it to keep your everything lined up. Yeah. All right. From there, we will go ahead and divide both sides by that 0.6 and 276. Right there, 276 better. 276 divided by 0.6 is 460. And that is the original price. That would be your original price for the camera. All right, chat. Yes, there's a 1 that's sitting in front of X. Whenever you have a variable, they assume you know that there's a 1. So if I have A, that's 1A. If I have B, that's 1B, and so on. So a variable standing alone will always have a 1 in front. So now we need to combine alike terms right here because both of them have X. So we need to combine alike terms. So that's going to be 1 minus 0.4. Well, 1.0 minus 0.4, that's just like 10 minus 4 is 6. So 1.4 minus 0.4 would be 0.6. And so that's where that comes from. Because we're doing 40%. When you're looking at this right here, 40% price reduction, you were taking 40% of the original price, and our original price is X. And so that's why it's 0.4X. All right. Anybody else before we go to the next one? All right. So the next one, your grandmother needs help. She has $50,000 to invest. Part of this is to be invested in non-insured bonds, paying 15% annual interest. The rest of the money is to be invested in a government-insured COD, paying 7% annual interest. She needs $6,000 in extra income from the investments. How much should be placed in each? All right, once again, give you a chance to write it, and we'll go from there. All right, so just to do a recap, we got a grandmother who has $50,000. She wants to invest it in 2 different accounts. One is paying 15% annual interest, the other one's paying 7% annual interest. And that's the main thing that we want to pull out of that, you know, the uninsured bonds, all that type of stuff. The main thing is the fact that you have 15% annual interest, and then the other one is 7% annual interest. And then she needs $6,000 in extra income to come from these investments. So with each account, we're going to pull what we know from it. So we have an account that's 15%, an account that's at 7%. So we don't know what we're going to deposit. That's what P is. The rate is 15%. So that converts to 0.15. And the rate for 7% converts to 0.07. And then the time is a year because we want to know how much will we earn in 1 year. Because remember, that's how she needs $6,000 to come from this per year. And so the reason why we need P, R, and T is because that comes from your simple interest formula. Wherein To calculate the interest earned from an account, P is your principal, which is your deposit or your loan. R is your rate. You know, you need to convert it to a decimal. And T is your time in years. You know, unless otherwise stated, you would have to convert it to years. All right, so right now we know how much money she has in total, and they haven't given us any relationship as far as they didn't say half and half, so we can't split it in half. They didn't say anything like 3/4 or anything like that. So whenever you have this type of scenario, this type of situation, the way you would handle it is that you would put X in one of the accounts, and then you would do the total minus X in the other. So here's 50,000 minus X. Now it does not matter which one you do. So we could have reversed it and put X in the 7%, 50,000 minus X in the 15%. Eventually you'll still come out with the same values. It's just that your calculation would be a little different versus mine, because I would be setting it up a little different according to the variables. But either way, you have to set up, one is going to be X, and then the other one will be the total minus X. So whenever you have this scenario, you have two different accounts. They don't give you any type of relationship other than one amount is going in one account, another amount is going in the other. You are going to do the total minus X, and our total is $50,000. Oh, my chat went away. Because what's going to happen is we're going to solve for X, and then whatever value we get for X, we're going to minus it from that total amount, that 50,000. That will give us the rest. So that's why it would be the total. That's why it would be total minus X. All right. Just like in the last problem when we saw, no, it was a problem before the first one, when we solved for X and then we added, you know, the 45 and the 25. This time we want to know what was left from the 50,000 after we made our deposit. We will subtract it from the 50,000, and that will give us the rest of the money.
Just a quick question. What
Yep.
does the I stand for? Does it stand for interest?
Yes.
I
Yes.
is interest. Okay.
Mm-hmm. Yep. Interest earned. All right. So now the way we would set up our equation, we're going to have a total amount of interest. Remember, we wanted that $6,000, and it's going to be equal to the amount of interest earned from the 15% account plus the amount of interest earned from the 7% account. All right, so we want both of those to add up to give us $6,000. All right, and so remember, the way we would calculate interest is multiplying P times R times T. So that's what we'll do in the next step. Now the total we just said was 6,000. Now for a 15% account, we're going to do P times R times T. Remember, P was X, R was 0.15, and T was 1 for 1 year, and that simplifies to 0.15X. The next one, P was 50,000 minus X, R was 0.07, and T once again was 1. And once you do your distribution, 0.07 times 50,000 is 3,500, and then 0.07 times X is 0.07X. And so we have these three pieces to put into our equation. And that would translate to this equation right here in green. If I can erase what I want to erase. So we have 6,000 equal to 0.15X, and that's the first account, and then plus 3,500 minus the 0.07X, which is that second account. And once again, I don't need the parentheses, but I just did that temporarily to show the pieces that we added. All right. So now, moving on to the next piece, we're going to combine alike terms. 0.15x minus 0.07x. See somebody in the chat. That 3,500 came from 0.07 times this 50,000 right here. That will give us 3,500. All right, combine alike terms. And that'll give us that 0.08x. There's my green. And I guess I'll erase it just to make sure we're clear. Then we'll walk through it. So now the next move is to subtract 3,500 from both sides. 3,500 will cancel. That leaves us with 2,500 equal to 0.08x. Then we'll divide by that 0.08. And the 0.08's cancel, leaving us with 31,250. All right. Questions before we look to finish off the problem?
Quick question, Professor.
Yep.
The formula is I equals P times R times T, right?
Yes.
We just, where, can you tell me where we use the formula in this problem?
Yep. Right here.
Right here?
Mm-hmm.
Okay, the P times R times T. P is equal X, R is 0.5. And then we did it for the same right here.
Yep. Yep. Did it twice.
So 6,000 is the interest rate.
Well, that was the total amount that she wanted per year.
So we put that equals to the 15% and add up. Okay, I got it.
All right, sounds good.
I have a question too.
Yep.
Why did you put the 50,000 in the 7%, but not in the 15%?
Well, you can't do both. You have to choose which one you want to do it. Because remember, this X is just going to represent how much you deposited into the 15%. And then this quantity right here is going to represent how much you deposited into the 7%. Because all you're going to do, what we're about to do next, is take what we solved here and then subtract it from the 50,000.
Okay.
Yep. All right. So going to what she just alluded to finish off the problem, we know X went along with the 15%. So that 31,250 is how much we deposited into the 15% account. Then to figure out how much we would deposit into the 7% account, we would subtract that 31,250 from 50,000, and that will give us 18,750. All right. Questions before we go to the next one? All right. So let's go to the next one. The length of an American football field is 200 feet, more than the width. If the perimeter of the field is 1,040 feet, what are the dimensions? All right, so here we're talking about the American football field, called the American football field. Just in case you didn't know, football everywhere else is soccer. So making sure they understand, everybody understand what's going on in this problem. That's why they call it the American football field. So we have two unknowns here. We have our width and our length. We want to know the dimensions of our field. The field is a rectangle, which is right here. Just in case anyone hadn't seen football, or got a rectangle for a football field, and so we need a width and our length. So the length is described in terms of the width. So what we can do is call the width x, and then call the length x plus 200, because 200 more than the width. Then also, since it mentions the perimeter of the field is 1,040, we can use our perimeter formula, which is P equal to 2L plus 2W. And plug in our values. So you notice here we have W is X, the length is W plus 200, and P, the perimeter, is 1,040. So that's what I got right here. And so I plug those in accordingly to our formula. And let me erase some stuff so we can walk through it. All right, so you plug in P, L, and W accordingly. 1,040 is equal to 2 times L plus 200, X plus 200, excuse me, plus 2 times X. So we would distribute the 2. So that's 2X plus 400 plus 2X. Combine your like terms. 2X plus 2X is 4X. And that 400 should still be there. See somebody in the chat. Oh, L is equal to X plus 200 because this statement right here, the length of the American football field is 200 more than the width. So that's why we have X plus 200. We call the width X and call the length X plus 200. All right. So now we want to subtract 400 from both sides. 400 on the right cancels, leaving us with 640 equal to 4X. And then to finish it off, divide by 4. 4's cancel, and X is equal to 160. All right. Problems with the 160 or questions about the 160 before we look to finish off the problem? All right, so X is 160. That means W is 160. And then your length is going to be 360 because you add 200 to it. And that'll be it because it's 200 more than the width. All right, questions? Any questions? All right. So when you're doing these word problems, well, first of all, make sure you try them out. But also, if you get stuck on one, you want to ask me a question, make sure you bring that one, to me, or whether it be to class or to, the email or whatever. Because when it comes to word problems, sometimes you can have a word problem and something specifically in that word problem could be causing you trouble. And I can pull out 5 word problems and it still not address the issue you had with that word problem. So if you're having a problem with that one, with a word problem specifically, make sure when you ask your question, you bring that one up so we can address what's going on in that word problem and make sure we get understanding for you. All right. So the last part of this section talks about solving for a specified variable. All right. So let's look at the same perimeter formula, P equal to 2L plus 2W, and we want to solve it for L. So in these problems, you won't get a solid answer like x equal to 2 or x equal to 5. You're going to have your variable equal to an expression. So you want to solve for that variable. You want to get that variable by itself. So we have P equal to 2L plus 2W. And you want to treat these other variables the same way you would treat numbers. They represent numbers. So in other words, when you go over here, still have my eraser up. Yep. So when you go over here, looking at 7 equal to 2L plus 5. If I wanted to solve for L, the first thing I would do is subtract 5 from both sides. So that's the same mentality that we're going to have over here. I have P equal to 2L plus 2W. I want to get L by itself. So what I'm going to do is subtract 2W from both sides. 2W will cancel on the right. And on the left, I have P minus 2W equal to 2L. Cannot combine those. They are not like terms. So P minus 2W is all I can do with that. All right. So now you're still trying to get L by itself. Divide both sides by 2. 2 cancels on the right, leaving you with just L. And your result is P minus 2W over 2. Now, before you go any further, as far as trying to reduce it or anything like that, we want to stop right there and make sure we're good with P minus 2W over 2 as our answer. Don't look at any of my arrows or anything like that. We'll talk about that in a second. But P minus 2W over 2 is a sufficient answer. All right. So what a lot of people would like to do here is to reduce because they see a 2 in the numerator and a 2 in the denominator. Now, there's nothing wrong with trying to do so, but we have to make sure we do it correctly. Now, notice my arrow up here. Got that top expression. This is the incorrect way of canceling out terms or numbers. Whenever you have a number in your denominator, you cannot just cancel it out into one term. So what you cannot do is cancel out those 2's and have P minus W as a final answer. The bottom arrow is the correct way of doing so. Whenever you have a denominator and you have multiple terms in your numerator, and remember your terms are split up by your minus and plus signs. So we have 2 terms, we have P and negative 2W. That denominator has to go into each term in your numerator. So you have P minus 2W divided by 2. That 2 goes into each term. So that leaves us with P over 2 minus 2W over 2. And now you can cancel out that 2 and leave you with P over 2 minus W. And this is another way of expressing that final answer. P over 2 minus W. All right.
What if we just leave it L equals P minus 2W over 2 over
That
here?
is fine. That's
fine. We don't have to go the extra step, right?
Nope, not at all. But I know people have done this in the past, so I'm just trying to prevent errors.
Okay.
Yeah. So like he just mentioned, like your classmate just mentioned, this answer is fine. But I know people have seen that 2 in the top and the bottom, and they want to go here. And so I'm just trying to prevent that from occurring. All right. So now what is mandatory though, if you go over here to my green box, that's just a random example. This is not anything, this has nothing to do with the previous problem, random example, but I want to show you when you do have to reduce. So notice that in our last problem, there was still a 2 left in that denominator. Whenever you have a denominator that's not going to fully divide into each term, you don't have to go any further. But if we had 4P minus 2W over 2, this 2 now can divide into the 4 and to the 2. So whenever you have that type of scenario where your denominator can fully divide into each numerator or each term in your numerator, that's when you must reduce. They are expecting you to do that. So we would divide, take the 2 into each term, 4p over 2 minus 2w over 2, and then that reduces to 2p minus w. And those are the scenarios that you are expected to actually reduce. But once again, if your denominator cannot go into each term in the numerator, you don't have to go any further. All right. Questions before we look at, I know we got at least one more here, but we'll see. Questions. All right. Well, let me scroll up too quick if anybody's copying. So that new problem down there is A equal to P plus PRT. We want to solve for P. Just trying to make sure everybody's good before I scroll up. All right. All right, so we have P plus P RT, and we're going to solve for P. So the first thing we want to do is recognize that P is in multiple places. Now your goal is to get a single P by itself. And don't worry about this stuff over here. I had somebody ask me a question in a previous class, so that's just something different. I might use it if somebody asks that same type of question, but we're talking about factoring here. Notice we have P that's in multiple places. So our goal should be to have a single P that we can solve for. So what we're going to do is factor P out of each term. So that's the reversal of distribution. We're going to undo that by pulling P out to the outside. That leaves us with 1 plus RT. So we took the P that was here and we brought it to the outside to have a single P. Once again, that represents, I won't say once again, just to reiterate, that represents the original expression. P times 1 is P, P times RT is PRT. So that's still this expression right here. It's just in a factored form. All right. So now we have P times 1 plus RT equal to A. To finish off our solving, we want to get P by itself, so we will divide both sides by that quantity of 1 plus RT. Now the 1 plus RT will cancel on that right, and that leaves me with A equal to, well, P equal to A over 1 plus RT as a final expression. All right. Questions? Any questions? So once again, try those out. See if you get stuck. Any problem you bring to the, to the class, or you want to talk about it in an individual session, we'll go ahead and knock them out. Make sure you have an understanding. I do want to touch on 1.4. I think this is 1.3. Yeah, just initiate 1.4 conversation, and then we'll close out 1.4 on next class. We're just talking about complex numbers. Somebody in the chat. Is there a good place to practice more of these? I think I know, so you can go back. When you go in my math lab, all you have to do is hit a similar exercise, and you can just keep redoing them. Now, if you run out of problems there, then I can show you. I mean, at the end of each section, if you go into the e-text, at the end of each section, there are homework problems as well that are more practice problems. So yeah, there's plenty of problems that you can check out. And then like Mr. Coley emailed me this weekend, one of your classmates emailed me this weekend, not this weekend, yeah, this past weekend, and he had a problem that he was trying out in the book and he needed help on the answer or whether the answer was correct or not. And I'll just check that, it's not a problem. So always feel free to email me about certain things you may have questions on, and whether the book provide the answer or not, I most definitely can help out. Yep, the perimeter formula is not. Do you just want to see that one, or you just want to know the perimeter formula? Because that's the perimeter formula right there. P equal to 2L plus 2W. All right, I guess you good. Okay, cool, you good. All right, so 1.4 starts off with complex numbers. Well, it talks about complex numbers, but it starts off talking about the imaginary unit. Let me erase some of this stuff. All right, so we're looking at the square root of I. That's the imaginary unit. Whenever you take the square root of I said square root of I, square root of -1 is I. That's your imaginary unit. Whenever you're taking the square root of a negative, you always have to implement I. Okay, and so why is that the case? Let me erase this stuff so we can walk through it. I don't want to get ahead of myself. All right, so why is that the case? So whenever you're taking the square root of anything, you're asking yourself what times itself twice will give you that number. So when I look at the square root of 25, that's going to be 5 because the square root of 25 is 5 times 5. Square root of 81 is 9 because that's 9 times 9. Square root of 121 is 11 because that is 11 times 11. Now, there's no such thing as a square root of negative, or what a square root of a -25 giving you a legit answer that's not imaginary. Because when you look at -25, there are no two numbers that are the same that's going to multiply to give you -25, because -5 times -5 will still give you positive 25. So the way we break it up, even if you're not going to necessarily write this out every single time, but this is the process that you should be going through. The square root of 25 is 5, but the square root of -1, that negative, is going to be I. So the result is going to be 5I. So like I said, you don't have to write that out every single time, but that's what's actually happening. You're taking the square root of 25 and the square root of that negative. And the square root of 25 is 5. Square root of -1 is going to be I. So then that means the square root of -81 will be 9I. The square root of -121 will be 11I. All right. So make sure we are good before we go to the next piece. So whenever you have a negative under the radical, an I should be somewhere to represent that situation, that occurrence. All right. Also, when taking the square root of values, you may come across values that are not perfect roots, but you are still expected to be able to simplify them as much as possible. So for example, something like the square root of 18. Now, you cannot take the square root of 18 evenly, but you can break it up into factors in which you can take the square root of. So when you look at the factors of 18, you're talking about 1 times 18, 2 times 9, and then 3 times 6. Well, only one of them has a factor that you can take the perfect square of. So you're talking about 9. And if you're not comfortable or used to what you can take the square root of and what you cannot take the square root of, the more you do these, the more you get comfortable with them. Basically, these come from your times tables. And if you have any uncertainty about it, just use your calculator. And the more you do it, the less you'll need the calculator. But 9 is a perfect square. So you would break it up, take the square root of 9 and the square root of 2. Square root of 9 is 3, and then 2 you would leave under the radical. Now, once again, this is one of those situations where they are expecting you to do this. This is just basically writing your number or your answer in its simplest form. And so they don't necessarily have to, prompt you for this type of answer. They would expect it from you. So here you have the square root of -24. Once again, 24 is not a perfect square, but we will be looking for factors that are perfect squares, the way we would break this up is by doing -4 times 6. So -4, leave the 6 under the radical, -4 and then -6. And so the square root of -4 is 2i, and then you leave your 6 under your radical. Another way you could see this expressed is 2 square root of 6i. You just got to make sure you don't extend that radical symbol over the I, but either or is fine. Questions on the breakdown? Now for the next one, is just me breaking down square root of 500. I showed 2 different ways. I had a classmate, a student that asked me about not finding the largest factor. So if you don't find the largest factor when you break it up, it's not the end of the world. You just have to make sure that you analyze your final answer and keep breaking it down if you need to. So the square root of 500, the most efficient way to do it is break it up into 105, because 100 times 5 is 500. Take the square root of 100, and that's 10. So your answer will be 10 square root of 5. Now let's say you didn't see 100. Let's say you saw 25, because you can take the square root of 25. So you will break 500 up into 25 times 20. The square root of 25 is 5, but that leaves 20 under your radical. If you were to analyze 20 further, you could see you could break 20 up into 4 times 5 and take the square root of 4. Square root of 4 is 2, and 5 times 2 right here will take you back to 10 square root of 5, which is what we had from the first breakdown. So either way, you'll get the same answer as long as you make sure that you've broken down your answer completely. You'll still get the same result. All right. We have one more thing to talk about before close it out. But any questions? All right. So your complex numbers, the way they will be written is a plus bi. So you'll have your real part plus your imaginary part, and you always write your real part first. And over in the green, I just have just examples of complex numbers. 2 plus 5i, -1 plus 3i, 7 minus 10i. The number 8 can be written as a complex number. You would just have 8 plus 0i. And then -12i can be written as a complex number. 0 is the real part minus 12i. So once again, this is the format of writing your complex numbers. Write the real part first, then your imaginary. That's your standard form. That's standard form. All right. So the next part is fairly simple if you remember combining your like terms. When you want to add and subtract complex numbers, that's all you will be doing is combining like terms. So if you have 5 minus 11i plus 7 plus 4i, you're going to add 5 and 7, which will give you 12. So you're adding your reals to reals, imaginary to imaginary. And you have -11i, positive 4i. That will give you -7i. Then the same thing happens when you do subtraction. Oh, got a question? Can you scroll up to the green part for a second? Yes, I can. There go your green. And like I said, those green were just random examples of how you would write a complex number. Yep, not a problem. And so if you're subtracting complex numbers, don't forget to distribute that negative first. And that's going to change the signs in each of the terms that's in that following parentheses. So that'll be -5 plus I plus 11 plus 6I. And then combine your like terms. -5 plus 11 is +6. And then I, don't forget there's a 1 in front of the I, plus 6I will give you 7I. All right, questions? Any questions? All right, so this is where we'll stop today. Next class we'll pick up right here. We will get into multiplying them and dividing them as well. But any questions before we go? All right. Well, you guys have a great weekend. Be safe, and I will see you on Monday. Have a good one.
Thank you, Professor
All right.
Tucker.
Take care.
Just one quick question.
Yep.
For homework, do we do 1.4?
It is up to you. You want to keep up with the lecture, you would at least get into 1.4. It's not mandatory. It's not the worst thing in the world if you're still in 1.3, or even if you're still in 1.2 by the next lecture. But if you're just trying to keep up with lecture, you would keep up with where we are. We're not finished 1.4, so you wouldn't necessarily have to finish 1.4, but get in there and start attacking addition and subtraction of complex numbers.
Okay, thank you.
All right, not a
Have a
problem.
good weekend.
All right, you do the same.
Thank you.
All right, everyone, take care.